Alright, hello everyone. In this video we're going to be enhancing our assembler to be able to write to a file. But before we get started, there's a actual bug um, from last time, so let's go ahead and uh, demonstrate the bug and then we'll go ahead and fix it since it's pretty minor. Okay, so bug exists in our safe truncate um, function. Should be pretty obvious to anybody who's paying attention. Of course, it wasn't obvious to me. So let's go to our main file. Actually, it's probably in our right file. Actually, you know what? We probably want to. This will be easier to demonstrate. So we can run the program now, and it'll do pretty much nothing important, except tell us that we need to provide an input file. And of course, it just dumps the contents of the file, if I remember right. The bug is in this function. So let's just go ahead and write some code here. We'll say sorry. We want to safely truncate some value, and we're going to get back in int 32. And so we're going to say here that the input is a 64-bit value. So we'll say, I guess input, that should work. We'll give some value. And here we'll say that input should equal output. And line will say values differ. Values match. So if I put in some value, we can see there that the values matched. The problem is, of course, if I put in a large enough value, they won't match. So I don't know what value would be, but let's just go ahead and do that. So here we see the values differ. And the whole point of the safe truncate was so that we know that we're collapsing a U64 to a U32 and we're not losing anything. This assert should be raised if that's the case. And so the actual problem here is that we're checking to see that the value we put in, which is a U64, is less than or equal to the maximum value of a U64, which of course it always would be. Let's get Visual Studio, give it some time to run. get loaded. I don't know where it went. There it is. All right, so if we step into the code, of course we want to actually step into the function. There we go. So the circuit skipped over, it's probably being optimized out. What we really want it to do in this case is for that to be U32. So if I, well, I gotta change this. And now if I run the assembler, they'll differ. That's odd. I wonder if the asserts are, let's see, so we have those under slow. We should be compiling the slow. So why is that not getting raised? All right, let's do this. We'll just assert something we know to be false. And not getting raised. So, wow. Oh, well, it could be because we never actually set the compiler flags anywhere. Does it recognize those as two different? Oh, yeah, okay. Wow. That's pretty bad. So I misspelled common there. That's good. There we go. Okay. So now we get, happens to be a crash if we run the program. There's an assert. Okay, so now we know why the asserts weren't happening. If we go ahead and run, now we get the assert. Because, again, we're going to lose some information there, which is what we're trying to protect against. So we know now that that's fixed. So let's go ahead and so we'll say here, correct misspelled variable. That's not needed, but that's needed, and that is too. And we'll say correct bug in safe truncate to uint 32. So now we can get rid of that stuff. And there we go. Okay, so That bug's fixed now. Actually, we found another bug in there. Kind of surprising. So the other thing that I wanted to do is there's a couple. I made some changes to my Vim config, and so I want to rename the build.bat to make that bat. It's not my favorite name, but that works with Vim settings by default, and it alleviates an issue where we have a build folder in the build.bat file. So now they're different. So that's fine. So there that is. The other issue I had was I wanted to rename some of the files here that we've put under common. They're not really C files. They probably should be header files. So I'm thinking the logging macros and types. So if we go to Tool, Chain, Common, we can rename logging to logging H, macros to macros H, types to types H, and then so then we have that. So rename files to H. Okay, so there's also some scripts that we have. And I had come across this set local functionality, and I've since realized you don't actually have to specify the end local. It's implied when the script finishes, so we don't need to do it, and I prefer not to have them at the end of the files. So looking through, it looks like we have under miscellaneous static check and to do, and VS I don't think has one. And that should be it. All right, so there we go. CM remove and local from batch files. Let's get that guy out of the way. All right, cruising right along. The next thing is that in our now make file, these tools I have available on in my path, but not everyone may, and if they don't, then they're going to get nasty errors in the output. So it adds a little bit more gunk in here, but I think it makes it a better experience overall. And if I remember right, I think we do both like that. So here I'm going to check once. What this will do is it'll check to see if CTEM is available in the wheres. So it'll do that, return you the path if it's available, and for something that's not, it'll give you back a little error message. So we have to pipe. I don't want this polluting up the output on the build, so we're piping the results to null, and we're just doing it based off of the error return. So when it's not found, you'll have an error level of not 0, and then we can use that where we have this guy. And then we need one for our CTAG as well. Sure. Yeah. And then we will just say eggs. There we go. Syntax is incorrect. I feel like it's not. It's probably this. And since we copy paste, probably that. And since we did copy paste, there we go. Okay. So that fixes that one. All right. All right, so that was all the notes I had for myself from last time. So going back to what we need to do for today. We currently are reading a file and we're not doing much with it. We basically output the size that the file is and then go ahead and output the entire contents. So if we take a look at our program, we'll go ahead and output so the contents for input, which is just the string hello from input asm. And if we run the program, the success is coming from right here. And of course you see 22, so that's the content size, and then the actual content, which appears to be hello from input with a carriage return. So what we want to do right now is make it so that we can write to a file, and we're going to bridge that gap and be able to read input, do whatever manipulation we want of it, and output it. So we already have a file started for reading a file. This will probably be a good spot for adding the output to a file. So we're going to have a file result returned. And then when we write a file, we're going to have to tell it where we want to write the path to the file, and then we're going to have an object called output that has the information in it. So let's go ahead and set up these guys. Give me 1 second. So if I don't think we loaded it. Common platform, Windows, file. So our the result of the file is basically going to be a status, and we could have it return just that status, but I figure why not put it into a struct, that way we can change it as we go. I wonder why this was a stat and why this was an int. Hmm. I don't think it should be, so let's change it. Yeah, that's weird. Okay. We need to do this output piece too. I have to find it in my notes here real quick. Sorry. For right now, I'm going to go ahead and define it here. Actually, it's going to need to get defined a little higher. That's okay. We'll put it right there for now. It's not a great spot for it. All right, let's get down to business to writing the file. So we're going to have a result. We're going to return that result. It's going to look very similar to the read file, but not as, there's not as many checks for it for some reason. All right, looks like I did call it file handle. So if it's invalid, these all work. for that. And then we actually get to just go ahead and straight write it. So we're going to verify that we wrote out the correct number of bytes. If we didn't, or sorry, if we did, we're good to go. Otherwise, what do we do up here? Let's double check. We did this. That's not all I wanted. All right, expected to write X bytes, but actually wrote Y bytes, I suppose. So this is going to be output memory size output memory size. If it's 1, then add the S, make it a little nice. Bytes written. Otherwise, and an unexpected number of bytes written. Otherwise here. So this is on the right file. We're going to do something similar here. Just cheat. And failed to write file blah. We don't need to do that. Failed to write. And then after all of that, close the handle. Okay, so okay. So we need to define U16. Here we go. Right. And do that. Blah, 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 blah. let's see, so what did we change here? We went from read to write, file share read to 0, null to create always, oh, open existing, and this to null here. Right, that's not defined, which it is entirely correct. Right, if I remember, we decided to just organize them by functionality, so this will be write, 3. Does that seem right? This looks like it's common, writes, sorry, reads, and writes. Seems right. Right. There we go. Okay, so the what we need to do now is actually call that code. So let's do, what do we want to do? Let's do this. Let's say that you have to specify a new argument called output file. So then down here, you can say write file results. We have to new up one of those output structures. Is that result equals the status? Success. Okay. Yeah. I guess we can do the same. I don't know. Okay. We're going to do it in here. So we're going to read first. That's going to be a success. We're going to output it. We're then going to write. And if the write file result status is successful, success, I guess we don't need the new that. Right, this needs to be output. So we're going to have to give it memory size and the memory, which if I remember right, is perfectly this. It's a 16 for some reason. Shouldn't be too big of a problem. All right. Can't convert. Yeah. What now? It's probably because this is a void star. No? Okay, I'm going to assume that that is just Crazy Town and things being more difficult than they need to be. Memory size. I want to see if that is okay. Interesting. This one's not. Yeah. Okay. All right, so there we go. So if we run this, there we go. If I do a dir of our data directory, there's no output file. So if I were to say data output copy has them, says this is successful, and of course the file's not actually there. Which is not expected. All right, to the debugger. All right, so our output looks like great. We have to now tell it all right. That looks correct. So we believe that we've outputted the correct amount of bytes. We have a path. Oh. Well, that's not good. We're writing back to the input file. Yes, okay, my bad. As usually. So we're going to say output path, and we're going to rename this guy input path. There we go. So now, there we have our output copy. It's the same content length. And there we have our original content. So what we have now is basically the most roundabout way to do file copies. So that's going to be it for this time. Next time we're going to actually start work on making sense of what our input file is and producing a different output file. So I hope you enjoyed this one, and I'll see you guys next time.